All right, guys, so today we're going to be looking at notes for 7.4. This is going to cover parallel lines and proportional parts. So the first thing that we kind of want to make note of that's really important is something known as the triangle proportionality theorem. This theorem states that if a line is parallel to one side of a triangle and it intersects the other sides, then what ends up happening is that it divides the sides into segments of proportional lengths. And I'll show you guys what I mean by that. So what this theorem is saying essentially is, for this particular instance, if my parallel lines, which are RS is parallel to TU, if I have those two parallel sides, then we can set up the following proportional ratios. We can say that I have x over y is equal to a over b. And so the kind of trick to kind of think about this here is that if I got these two parallel lines here, what's going to happen is that this proportion is going to write itself. So if I just draw a little fraction bar here, we see that I got the x over y. That's equal to a over b if I draw my fraction bar there. So when I got two parallel sides like that, the proportion is going to pretty much write itself. So we're just going to practice kind of setting these things up using letters, and then we'll look at some examples that start to use numbers and equations. So what we're going to take a look at here is the first example down here. So it says complete each statement using the figure below. If I take a look at this here, and we're just going to use our highlighters. If you got any highlighters or colors to kind of help make things be a little bit more clear visually, I'd recommend taking those out at this time. So it says complete each statement using the figure below. I can see here that LW is parallel to TS. And what I'm seeing here is the way that they're setting up their ratio is we're working with RW, and then they're working with WS. So if they're going to set up a proportion here like this, when they set up their ratios, they have to be consistent. So I got yellow over blue is going to have to be equal to yellow over blue. And we see here that the yellow is given by RL. The blue then is going to be that corresponding piece here, which will be LT. So we should be writing LT right here. And the next one, okay, for number 2, we'll erase this and kind of go through it a second time. Now, we'll just use different colors here. It says RW, it's the first thing we got on top. RW is this piece right here, over RS. Well, RS, that represents the entire length of that side of the large triangle. So when I set this up, the bottom piece should be that same whole other length, which is RT, and that ends up matching up. So it's really just a matching game here at this point. I'm really just setting this up then as RL. It's going to go on top. So when you color code it, it makes it real easy to see what exactly should go either in the numerator or denominator of these proportions. So we'll go through this next part a little bit faster now. And there's a couple of different ways you can set this up. You can set this up as like we did up here at the top, where we have x over a is equal to a over b. Kind of similar to what we did here on number 1. Or you can also set this up with the green and the purple or pink that I have here, where it's, you know, one of those pieces is going to be written over the whole length of that side. And you'll see how this kind of connects when we start looking at some more examples with actual numbers involved. So we'll run through this a little bit faster now. So we're looking at TA on the top. Here's TA. AR is on the bottom. So AR, I'm looking at this. So if my fraction is TA over AR, then my fraction that it's equal to, my other ratio that it's equal to, should be matching up the exact same way. So I should have TI over OI. Similarly here, if I go to the next one, and we'll use different colors here to kind of differentiate. TA, here's TA over TR. Well, TR is the whole thing. It's really just a repeat of pretty much what we just did on the last one. So if I do yellow over pink, well, my yellow piece here should be TI. So this should be TI. Okay, and so we'll kind of look at how this is going to make sense as we start to look at some examples. There's a lot of examples in today's notes. We're not going to look at every single one of them. Okay, but for right now, we should hopefully be seeing that for number 5, it says find the value of x, show work, and box your answers. I see right off the bat here that I got my parallel lines. I know that these are parallel because I see the little arrow. That arrow on a segment indicates that they're parallel to one another. So if I'm going to set this up, the ratio is going to write itself. Here I got 8 over 6 is equal to, well, in this case, x over 15. So it writes itself. So let's actually write that out now. We got 8 over 6 is equal to x over 15. Right? What I'm looking at here is the green I'm setting at the bottom of my ratios, and the yellow I'm setting at the top. Okay, so if we set this up now, we can go ahead and cross multiply. If I cross multiply, I'm looking at 6 times x is equal to 8 times 15. 6 times x gives me 6x. If I multiply 8 times 15, we end up getting 120. From here, we divide both sides by 6. Doing that tells us that x is equal to 20. So there we have it. We found x. X is equal to 20. So if I look at number 6, okay, number 6 is pretty much a similar setup. Remember that the ratio basically writes itself, so I'm doing yellow over green is equal to yellow over green. Here are my yellows, and then here are my greens. So if I'm going to set up my proportion here, my two fractions, my two ratios, I need to make sure that I know both yellows and both greens, that something is describing those yellows and greens. Well, I notice here that I currently don't know what the length of that yellow segment is. But if we look at the total here, okay, we can see that the total of this is 30. So if I take away the green part of 9, I'd be subtracting out 9. That tells us that the yellow piece there would be 21. So if I just subtract that out, now I know that the yellow piece is 21. And so now we just write our ratios. Okay, remember when the lines are parallel, the ratios pretty much write themselves. So this is x plus 6 over x. And then this will be 21 over 9. So it's equal to 21 over 9. And that's really how the triangle proportionality theorem works. And then from here, we're comfortable cross multiplying, so we'll cross multiply. Got 21 times x is equal to 9 times x plus 6. If I multiply this out, 21x is equal to 9x plus, well, 9 times 6 is 54. From here, I want to solve for x, so I'm going to subtract 9x on both sides. If we do that, we end up with 21x minus 9x gives us 12x is equal to 54. If I divide both sides by 12, we end up getting x is equal to 54 divided by 12, which is equal to 4.5. So you'll notice that for our x value here, we ended up getting a decimal, and that's okay. That happens sometimes. We'll look at one more example of this real fast, and then we'll go ahead and kind of cap things off with triangle proportionality theorem. So why don't we take a look at number 8? We'll skip number 7, okay? If you would like to pause the video and try number 7, go ahead and pause it. Try setting this up, and then cross multiply and solve for x. If you want to check your setup real quick, I'm not going to just solve it all the way through. I'm just going to set it up. Should be 6 over 4 is equal to 2 plus x over 5. If you cross multiply, you should have gotten x is equal to 5.5. Okay, but let's go through number 8 real fast, just because these are scenarios where it kind of makes us do a little bit more work. So similar to the one that we did up here, number 6, we can find the length of one of those missing pieces if I take the total and subtract out one of those parts. So here my total is 42. So this whole thing is 42. If I take out the 16, I'd be looking at 42 minus 16, and that gives us 26. So what we understand now is that this piece right here that was missing is 26. So now we just set this up like we've been doing. We pretty much just been looking at yellow over green is equal to yellow over green. So here are my yellows. Here are my greens, right? One thing to keep in mind though, this only works if these two lines are parallel. It's the only time it's gonna work. Okay, I'm gonna say it again because this is something that gets messed up quite a bit. This little ratio where it writes itself only works if the lines are parallel here, if I got these two sides parallel, which we do have that, so we'll go ahead and set it up. I got x plus 5 over x is equal to, well, on the right-hand side, yellow over green would be 26 over 16. If we go through the process here and we cross multiply, what I'm looking at is 26 times x is equal to 16 times x plus 5. From here, if I work it out, 26 times x is 26x. 16 times x is 16x. And then 16 times 5 gives us 80, so plus 80. From here, we would subtract 16x on both sides. That would give us 10x is equal to 80. So if 10x is equal to 80, my last step here would be to divide both sides by 10. That would tell us that x is equal to 8. Okay, so just remember for triangle proportionality theorem, if you're going to want to go ahead and use colors here, yellow over green equals yellow over green. And again, this ratio, triangle proportionality, only works if these lines are parallel. Okay, so if the lines are parallel, then those pieces are proportional. So if that's the case, then we have something known as the converse. Remember, the converse is the same statement, just pretty much written backwards. So the converse of the triangle proportionality theorem says that if a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then that's enough information to tell us that the lines are parallel. So let me kind of explain what this is really saying using math symbols. So this is saying essentially that if I got x over y is equal to a over b, if that's proportional, meaning that it simplifies to give me the same quantity, then we can verify that RS is parallel to TU. In other words, that these guys are parallel if these pieces here are proportional, the x over y and the a over b. Okay, and so we'll look at a few examples of this. We're not going to look at this a whole ton. For where it says draw a conclusion, they give us some values here. Let's go ahead and put that on the picture given to the right. It says if EH equals 2, so this is 2. If HF is 6, DG is 1, and GF is 3. What we're basically trying to test out here is what we just said, the converse of the triangle proportionality theorem. So in other words, if I set up my ratios like this, if they're proportional, meaning they simplify to give me the same number, then that means that the lines here, DE and GH, would have to be parallel. So let's set up our proportion. I got 1 over 3 is equal to 2 over 6. If I simplify these fractions, and again, you can do this by hand or do this using the yellow calculator, 1 over 3 simplifies to just 1/3. It's already in simplest form. But 2 over 6, I can divide the top and bottom by 2. If I divide the top and bottom by 2, this simplifies to 1/3. The fact that I got the same number simplified here means that it's proportional. So if those corresponding pieces there are proportional, then that means that DE has to be parallel to GH, right? And this is us using the converse of that triangle proportionality theorem. Okay, the next section should hopefully look a little familiar. We're looking at the triangle midsegment. So a midsegment, and you're going to want to pay very careful attention to this definition. Okay, the midsegment of a triangle, this is going to be a segment that connects midpoints of two sides. So, and we'll draw one out here off to the side here. A midsegment, again, just connects the midpoints of two sides. So let's say, for example, this is a midpoint, and if that point is right in the middle, that means that these pieces here are congruent. And if this is a midpoint, then these two pieces are congruent. So what a midsegment is, it simply is just a segment that connects two midpoints together. So here's the first midpoint, here's the second one. A midsegment just connects two of those together. And so one of the things that you want to make note of for a midsegment, understand that your midsegment is going to be parallel to the third side of a triangle. Okay, so what we're saying here is this. Let me actually do this in a different color so we can see it visually. So we're saying that the mid-segment is parallel to the third side of the triangle. So that would indicate that that mid-segment is parallel to this third side here. The third side is the side that it did not connect. And then the other thing is we want to make sure that we understand that the mid-segment is going to be half the length of the third side of the triangle. So in this particular example, if I tell you that this third side here is 40, okay, the mid-segment would be half that amount. So the mid-segment here would just be 20. And so we have something known as the triangle mid-segment theorem. This says that if I got a mid-segment, okay, and we'll fill in these blanks here in just a second, but I really do want to focus on this mid-segment theorem. We're going to write this down here in this white space. Your mid-segment in this particular case, and for every case, is going to be found by taking 1/2 of that third parallel side. So again, that mid-segment is going to be found by taking just 1/2 of that third parallel side. And so in the context of this particular picture, okay, this mid-segment here would be JK. Remember, mid-segment connects two midpoints together. So this would end up being JK. That length would be equal to 1/2 of that third parallel side, which that third parallel side is FG. So in this case, it'd be 1/2 the length of FG. And that would be the way that we find the length of that mid-segment. And we see an example kind of up above here with that triangle that we drew off to the right. And so what we're going to fill in the blanks here is going to be if J and K are the midpoints of FH and HG. So the fact that this is a midpoint right here would mean that these two pieces here, FJ and JH, are congruent. So we're going to write that out. FJ is going to be congruent to JH. And then similarly over here off to the side, if K is a midpoint, then that means that HK will be congruent to KG. Okay, so we'll look at some instances where we do have a mid-segment here, and this one's a little bit challenging to look at visually, so again, we're going to rely on those colors to kind of help us see this one. So example 1 says, in the figure X, Y, and XZ are mid-segments of triangle RST. Find each measure. Okay, so they're telling us here that XY is a mid-segment. We just said that a mid-segment is going to be parallel to the third side that it doesn't connect. So check this out. That mid-segment XY is going to be parallel to ST. They also told us that XZ is a mid-segment. So XZ connects the left and right side, so it's going to be parallel to that third side, which will be the bottom one. So I got two mid-segments there, and they're color-coded now, yellow and green, with their third parallel side. And so now we can go about answering the questions here. The first question is asking us XZ. They want us to find the length of XZ. Well, XZ is located right here. I don't know what it is. I'm just going to call it X. And recall that to find the mid-segment, our formula that we rely on here is that the mid-segment is equal to 1/2 of that third parallel side. So in the case for XZ, XZ represents the mid-segment. So in my formula, this is going to be X equals, well, it's half the length of that third side. So 1/2 of RT, which is that third parallel side. Well, we know that RT right here is given by 13, so X is equal to 1/2 of 13. 1/2 of 13 is 6.5. So in this case, XZ, we labeled it as X over here, is just 6.5. We're going to do something very similar for ST. ST here is labeled here in yellow. Okay, so now I'm looking at the yellows. So I'm looking at this guy, this mid-segment of 7, and this third parallel side of ST. So if I'm following that mid-segment formula, this time they gave it to us. The mid-segment is 7. That's equal to 1/2 of the third parallel side, which is ST. So if I want to solve this, what we're looking at here is I want to get the ST by itself. So how do I cancel that times 1/2? Well, normally we would say divided by 1/2, but if I do that, that looks a little bit weird. So one thing I do want to mention here is that if you ever want to cancel out the multiplication of a fraction, you can do so by multiplying by the reciprocal. So if I multiply by 2/1, I'd have to do that to both sides. What ends up happening is the 2/1 cancels out with the 1/2. And so what I'm left with here is 2/1 times 7 is just 14 is equal to ST. So we found ST. This was an instance where we're just working backwards. The last question here is asking us find the measure of angle RYX. Okay, I'm going to clean this up because we've drawn a lot on this triangle, and I just want to make things clear here for finding RYX. Okay, RYX, and what I'll do is I'll mark RYX here in red. RYX is going to be this angle right here. Okay, well, what I'm realizing here is that we talked about the mid-segments being parallel to that third side. These two sides would have to be parallel because they said XZ is a mid-segment. And what I have here is a transversal going through. Here's my transversal. So what I'm seeing here in red, that angle they want us to find, RYX, and 124 are alternate interior angles. Okay, so if those are alternate interior angles, that means that they're congruent. So the measure of angle RYX then is just going to simply equal 124 degrees. Reason being, those are alternate interior angles with the 124 degrees. Okay, moving on to the next section here, we're looking at proportional parts of parallel lines. This one looks a little bit more overwhelming than it actually is. Okay, and let me explain this one kind of in a much more simple way. It says if we have 3 or more parallel lines and they intersect 2 transversals, then what ends up happening is they're cutting those transversals proportionally. So it's similar to what we did in the beginning where the ratios and the fractions, the proportions, they write themselves. So in the case here, and I'll kind of highlight this to kind of emphasize here, what we're saying is that this is going to have 2 transversals, which these are my transversals. The parallel lines are cutting those into proportional pieces. So we could say that here essentially AB over BC would be equal to EF over FG. It's pretty similar to what we did at the very beginning of the notes. Okay, so if you want to write that in the blanks here, we can say essentially that, hey, AB over BC, yellow over green, equal to yellow over green. And again, this ends up happening if you have 3 sets of parallel lines and they are intersecting 2 transversals. We could also look at this as, and let me mark this here in our ratios here. This was the yellows on top, the greens on the bottom. I can also take a look at this in the context of, hey, AB goes with EF, and I can compare that to this entire length here of AC. So this would be blue over pink equals blue over pink. So we could also end up saying that for this particular one, I got AB over the whole thing of AC would be equal to blue over purple again, so EF over EG. And we just said that we marked this with colors. This is set up in the fashion of blues on top over purple on the bottom. Okay, so a couple different ways we can set up these ratios, and you could also do BC on top, like green over pink, green over pink. Just understand that the 3 parallel lines intersecting 2 transversals is going to set these little pieces up proportionally. So in the context here, if I look at A, it says use the figure to the right to complete the proportions. I'm looking at CB first. CB, this is yellow, goes with yellow on top with EF. And what they're comparing on the bottom is EG. EG represents the entire thing. So that means it would represent the entire thing here of CA. CA is what I'm missing here on the left-hand side. Going through the next one here. That's our part there in blue. The next one is asking us about GD and GF. Let's take a look at GD. GD. Okay, let me actually erase this so this doesn't get confusing. GD would represent this entire thing here. So GD, the entire thing is on top, over GF. GF here is just this piece here. So it's green over blue. And the blue's on the bottom, so AB here. I'm looking at the whole thing there. That should go on top. The whole thing here on top on that other side is going to be DA. So we're really just looking at a matching game for these situations here. And then lastly, we'll clean this up again. We'll look at CE over AG. And we'll just do this one just in regular colors. CE, it's looking at that top little tiny triangle over AG. So I'm looking at green on the bottom, red on the top. So if DG is looking at this large triangle as a whole, like this big one right here as a whole, then what I'm looking at here is comparing the part that we haven't highlighted here. We have AG. What we haven't highlighted here yet is DG. So let's kind of run through that back because I think the colors are probably going to get confusing here. So we looked at CE over AG, and then we're looking at DG, which would be this whole thing. Okay, that's in response to the whole part of the big one. So it's going to correspond to this little piece right here, which is D. And sometimes these force you to kind of look at it a little bit more closely. But understand that we're really just looking at a matching game here. So we'll move on to the next section of the notes here to kind of wrap things up here. And it says here, find the length of KL. We've already kind of done examples like this already, so we'll skip example 8. Example 9 says determine if QT is parallel to RS. This was us looking at testing to see, hey, are these fractions here going to be proportional? So remember how these kind of write themselves if they're parallel? Well, if they're parallel, these are proportional. And if I look at that statement backwards, the converse, if I set up these ratios, 36 over 80 and 18 over 38, if these simplify to the same amount, then we're going to end up seeing that they're proportional, and that would tell us that the lines have to be parallel. However, if we simplify 36 over 80, what I end up with here is 9 over 20 is equal to 18 over 38 simplifies to 9 over 19. Notice that these values are not the exact same. They're not equal, so not proportional. That means that in this case, not parallel for QT and RS. Okay, we'll do one last example here where we're looking at those triple parallel lines. Guys, when you do the triple parallel lines here, it's similar to what we just did. The fractions kind of just write themselves. It says find the length of AB. I don't know what AB is. It's right here. I'm going to call it X. So if the fractions write themselves, take a look here. I got 24 over 32 is equal to, if I look here, 27 over X. Then you just cross multiply. If we cross multiply here, I'm looking at 24 times X is equal to 32 times 27. 24 times X gives us 24X. If I multiply 32 times 27, if we type that in the calculator, we get 864. From here, divide by 24. We see that X is equal to 864 divided by 24 gives us 36. So we found X is equal to 36. However, they asked us to find the length of AB. If you look at AB, though, we labeled it as X. So AB is simply just what we got for X, which is 36. Okay, and so that'll conclude today's notes. What I recommend you guys do is read Canvas. Canvas should have a reduction of the number of problems you have to do for the assignment. Okay, so for the assignment 7.4 homework, understand that this is due the next day that it's assigned. So this will be due on Friday, February 2nd. So if you want to just put that on the top somewhere so you don't forget, due February 2nd, Friday. So like I said, check Canvas. Your teacher's going to reduce the number of questions that you have to do. So don't do all of them. Just hold on, hang tight, read Canvas or ask your teacher to see what problems that you're only required to do. Okay, if you have any questions or concerns, reach out to your teachers, go to tutorials, and make sure that you're doing what you can to ask for help.